Today I'll be teaching about stoichiometry. Stoichiometry is the process of getting the products using the reactants. The first part of stoichiometry is finding the excess and limiting reactants. The excess reactant is the one that creates the most of the product, and the limiting reactant is the one that generates the least of the product. The difference between the limiting and excess reactant is that the reaction can still continue when the excess reactant is gone, but it cannot continue when the limiting reactant is gone. First, let's define the excess and limiting reactants. For this reaction, let's start with C2H4O2, which is acetic acid. So first you use what's given to find the moles of what it has. So right here we're given 0.833 molar solution, which is just a concentration. And then you have to find the number of moles, and you don't know that. And then you also know you have 250 milliliters, which is 0.25 liters. And then you multiply 0.833 and 0.25. And then you get 0.20825. And then you use this to find the moles of CO2, and you do that by multiplying it by the molar ratio. And then you multiply by the molar mass. And let's take out our calculators to do this. So 0.20825 times 44. 0.01. That's 9.16 grams of CO2, and this CO2 is how much the maximum it can generate by using all of the 250 milliliters. So now that we found the first reactant, we're going to do the second reaction with the sodium carbonate, which is also known as baking soda. So right here we have 26 grams of NaHCO3. You have to multiply that by the molar mass, which is 84.007 grams, divided by 1 mole, and then you multiply that by the molar ratio, which is 1 to 2. So 2 is on the bottom for NaHCO3, and then 1 is on top for CO2. And then you have to multiply that by the molar mass again. 44.01 grams divided by 1 mole CO2. And then let's get out our calculators and do that again. So 26 divided by 84.007 times 1/2 times 44.01, and that would be 6.811 grams. So since sodium carbonate generates 6.811 grams and acetic acid generates 9.16 grams, acetic acid would be the excess reactant and sodium carbonate would be limiting reactant because it's less. So to find the limiting reactant, what you have to do, you have to find the grams that each reactant produced of the product. So basically, first you get the grams given, which is usually what you get, and then you multiply it by the 1 mole divided by molar mass of what you're given. Basically, all this does, it gives you the number of moles that you want. And then after that, you're converting it to the other side by using the coefficients. The coefficient make it the moles of what you want. And after that, you multiply the molar mass to get it back to the grams of what you want. And once you get that, you can compare the both, and whichever one's less, that's limiting reactant. And we use limiting reactant to find out how much we have. So now that we know the limiting reactant is sodium carbonate, we use 26 grams of sodium carbonate, which is NaHCO3. You multiply it by the molar mass, which is 84 point. And then grams, and 1 mole, and then you multiply it by 1 mole, 2 moles actually, 2 moles NaHCO3, and then 1 mole CO2. Right after that, you have to multiply by the molar mass, which is 44.01 grams of CO2 divided by 1 mole CO2. Basically, what you're trying to do is you're going to try to cancel out for the units that you want, which is grams CO2. Write it out up here, grams CO2. So if you start grams here, you go grams here. So what's up has to go down. It's just gravity. And then you have moles of sodium carbonate. Moles of sodium carbonate goes back down and crosses out. And then right here, moles of CO2, moles of CO2, it crosses out. And then what you're left with is grams of CO2. And then the thing you're left with is 6.811 grams of CO2. One of stoichiometry's goals is to find out what will happen when you do the reaction and how much product is created. And when we do this, you need to have something to compare it to. So our comparison is the theoretical yield. This is what we calculated using stoichiometry. So this is the 6.811 grams of CO2. So what this will do is basically it serves as what we compare it to. It gives us a fraction. This is the whole. So this gives us our percent yield. And in order to find that, we divide our theoretical value that's our theoretical value, which is this, divided by experimental value, or actual value. And then you multiply it by 100 to get the percentage. So right now we have our theoretical. Let's go do the experiment so we can get the experimental value. So right now we're looking at the beginning of the reaction. I haven't turned it on yet. Like, I have to tip the balloon, but after that it will create the carbon dioxide gas. So let me tip the balloon. So right now the reaction's basically done. It's just in its latter stages. It's not going to explode. So right now I'm going to measure the pressure and the volume. So now the reaction's over. We can go find the experimental yield using Pivnert, and we can find out if this is actually a reaction that went really well. So after doing the experiment, I figured out by measurement the pressure, the volume, and the temperature. And right now we have to find the number of moles. And if you guys look at the gas laws video, you can see that this looks like a lot like Pivnert, and this is what we're looking for. So what we set up for is PV equals nRT, and since we're looking for N, which is number of moles, we simply divide by RT on both sides. So PV equals, divided by RT equals N. And R is always 0.0826, and then temperature, it was 298 degrees Kelvin, which is standard temperature and pressure. The volume was 0.6 liters. The pressure was 5.1 ATM. So when we plug this into this formula, we get 5.1 times 0.6 times 0.08206 times 298 Kelvin. And we find out there's 0.12 moles, so there is 5.51 grams of CO2. And now that we have the experimental, which is 5.51, what we can do is we can get the 5.51 grams CO2 divided by the 6.81 grams of CO2. This is the theoretical and this is the experimental, and multiply by 100 and you get the percentile. And most kids, what they do is they switch these up, but a good way to remember it is it's like there's original and there's the new, and you're trying to find what's new, and by doing that you have to get, and by doing this you get 80.91% yield. And this is actually really good, and in most of your labs you wouldn't find this great of yield. You'd find something like 70 or below. So this is actually a really rare occurrence. This is a great idea. I'm going to totally do it. Alright. My bad.